In this problem, we are given 5 different shapes, and we are asked how many combinations of having these shapes in a row is possible when the smiley face is not at either end. The first thing to do is to calculate all of the possible positions without any restriction, which means that one possible combination would be the spade being first, or the club could have been first, or the smiley face, etc. So, taking into account that the smiley face could possibly be there as well as all the other shapes, then there would be any one of those 5 symbols could be in the location in the first possible location. Then, whatever one we chose, there would be 4 left for the second location. Since any one of the 5 could have been selected for the first location, then any one of the remaining 4 could have been selected for the second location. There would be 5 times 4 equal to 20 possible combinations just for those first 2 locations. There would be 3 possible symbols for the third location, and that symbol placed in the third location could go with any one of the 20 possible combinations for the first 2. So therefore there would be 60 possible combinations for the first 3 locations. There would be 2 possible symbols for the fourth location, and since those 2 symbols could go with any of the 60 possible combinations for the first 3 locations, there would be 2 times 60 or 120 possible combinations for the fourth location. For the last location, there would only be one symbol left, so if we didn't care about any restrictions on the symbols and we just wanted to figure out the number of combinations of placing all of those symbols in a row, we would have 120 possible combinations for putting those symbols in a row. So there's 120 possible combinations without any restriction. Now let's assume the smiley face was placed in the first position. There would be 4 possible symbols to place in the second position, 3 for the third, 2 for the fourth, and then there would be only 1 left for the last. So when the smiley face is placed in the first position, there are 4 times 3 times 2 times 1, which equals 24 possible combinations. Likewise, if the smiley face was in the last position, there would be 4 times 3 times 2 times 1, which equals 24 combinations for the smiley face to be in the last position. Therefore, the total number of combinations without having the smiley face on either end is equal to the number of combinations without any restriction, which is 120, minus the number of combinations where the smiley face is placed first, which is 24, and minus the number of combinations where the smiley face is placed last, which is also 24, which is equal to the answer 72.